Jon, welcome to Climate Optimists.
It's great to be here. Thanks.
So, to start you off, when it comes to efforts to address climate change, what makes you hopeful?
I have to say that it's often hard to be an optimist when you talk about climate. So ironic that that's the title of this series. I try very hard not to be a pessimist, and maybe I'm more of a realist than anything else. But I think when I think about what makes me hopeful, it's the generations coming through education right now. They're learning more about climate and natural processes than I certainly did in school. And they seem to care more about the degradation of the planet. They're asking more questions and they're supporting more companies that share their own values. My daughter is taking chemistry in high school this year, and she chose to do a paper on carbon as emissions from buildings. Now, I have no idea where she got that idea from, but I think that would not have been a topic even to talk about when I was in high school. So I think we're looking at generations that have the climate change topic already on their radar, and we won't have to spend a lot of time educating them in the way we've had to educate ourselves and current generations in the workforce today about the why and the how. So I think and I hope solutions are going to come quicker.
Yeah, and it seems like, to your point about the education piece, if there's already that awareness, then it's much easier for them to connect the dots on, the viability solutions, or hey, this thing over here will have this downstream impact. Where I think if you're not as plugged into climate change, there's maybe this association with like, well, it's obviously bad, but people don't understand the connections, which is often important as we're talking about certainly planning things like buildings.
Absolutely. Yeah. And I think they also have so much more access to data right now that it's so easy for them to look up a company and the company's values and see what they're doing about climate change and carbon reduction and whether or not that's where they want to spend their money on clothes or memberships or music or what have you. That they can make decisions faster based on their own ethos, which is kind of empowering.
It is, yeah, and their collective buying power definitely has the potential to change business for sure. So let's dive into topic at hand, kind of big picture. How much of global greenhouse gas emissions are sort of linked to buildings, and then how does that shift at all in terms of numbers in the U.S.?
Sure. Well, it depends a little bit on the source, but trends in the data show that globally between 40 and 42% of emissions are linked to construction in the built environment. This includes both operational emissions and embodied carbons of the materials that we use to construct the buildings. In the United States, fossil fuel burning attributed to residential and commercial buildings accounts for roughly 29% of total US greenhouse gas emissions. Improvements in energy efficiency have led to emissions reductions in these sectors since the peak in 2005, but we still have a long way to go.
Yeah, I can imagine a built environment that was in place well before we were taking these sort of measures. So you mentioned operational and embodied. So there's sort of this, obviously the construction phase, people can envision their emissions there. And then there's the subsequent, years of operation that the building is in place. And those are kind of your two primary buckets.
Correct. Yeah, we've got sort of looking at, when we think about operational carbon, it's really everything that makes the building tick. So fuel is used to power the building, and that can be oil, natural gas, coal. That can be electricity. That can be a series of renewables that can happen on site or off site. And a lot of people think, well, we'll just make the energy source at the building cleaner, and we'll solve the problems. And some of that is true, but we've got so many buildings that are dependent on our energy grids right now, and the energy grids are powered by usually a combination of fuels. So you really have to go back, not just from the building, but you have to go back to the energy grid, to the power company and supplier, and say, well, what is actually creating this energy? And
right.
Fortunately, anybody can do that. We've got that information is free through the government. So you really can sort of start to open your eyes in terms of not just how much power are we taking on site. But even if we reduce that on site, the power that we're using, what is the fuel that's creating that? And that's often step one in understanding how do we get to something called carbon neutrality or climate neutrality is really getting to that point where we understand where all of our energy is coming from, and we can either replace it with something cleaner or we can offset it with until that cleaner replacement is found.
In other words, we have a power mix sort of nationally that relies on a combination of fossil fuels and non, and that power mix presumably is going to continue to clean itself up. But there's going to be a while before we're 100% carbon neutral, and so even if you've reduced the amount of power you consume, you're still relying on a certain amount of electricity that's been produced using fossil fuels.
Exactly. Anybody who's connected to the public grid is going to is more than likely relying on some percentage of fossil fuels. There are a few places in the country where that isn't the case, but the overwhelming majority are.
So I know in having my limited knowledge of building, but understanding that buildings drive a lot of everything else in terms of how communities are put together. How are emissions from transportation linked to buildings? Where does that fit into the mix? Knowing that the kind of buildings you're building impact transportation options.
Well, in some ways, it's less of a question about density versus sprawl related to buildings, and more about the fuel sources that are used to be powering. Let me try that again. Sorry.
Go for it.
In some ways, it's less of a question about density and sprawl related to buildings, and more about what fuel sources are used for the energy powering the buildings, as well as how the materials are moved to a project site. When we think about how people move to a project site day to day, we know that they have the option of getting into a car and driving, which is, especially as an individual, is probably one of the most polluting and certainly a high carbon emissions factor. There's also a lot of cleaner solutions like walking, bicycling, and using public transit. Um, while these are all good options and we should continue to promote them, and density certainly does promote those, they aren't always considered when looking at the building's carbon footprint. We usually try to think about what's physically there and how it's being powered. So one of the ways we start to think about that is, can we source materials locally or within a certain radius, from our project site or our building, because that will decrease its carbon footprint through its transit. When we talk about carbon in building materials, we talk about embodied carbon being the carbon number represented from the material's entire lifespan. And that includes everything from extraction from the ground, whether that's mining or growing, to moving that material to a factory or processing plant, creating the product, moving it to the building, installing it, the lifespan of the product, and then removing it if the building is demolished. The transit of a product, while it is representative of some level of carbon emissions, because it's most likely coming on a truck, and
Sure.
sometimes at a very long distance, sometimes it's even on a boat to a truck, the transit itself is actually a fairly small amount of the total carbon, embodied carbon for a product. Now, obviously, that varies quite a bit, and it varies based on the product itself and the level of manufacturing, because that was going to impact higher or lower carbon emissions. But trying to find materials that are produced near a building or near a project is going to start to minimize that carbon footprint for those specific products. Um, the other is thinking about when you look at a product to put into a new building or to replace an existing piece of a building, um, what is the manufacturer doing on their end to minimize the carbon footprint of their whole process? So, are
Right.
they looking at renewable energy at their manufacturing plant? Are they using hybrid or electric vehicles to deliver? Um, certainly, um, the other impact that density versus not in cities has is that typically the denser the location, the more variety of access to materials you're going to have in that area. Um, so we see there are some benefits to dense urban environments, but it really comes down to more the product itself and the process that that product goes through, and understanding that when you're determining the carbon impact.
So it sounds like it's complicated in terms of figuring out, the embodied carbon material. I'm guessing materials, especially for a bigger building like concrete and steel, are probably more carbon intensive. And I assume they're. I mean, we've obviously talked on this podcast about green steel and low emission low emission concrete. Excuse me. Um, are those things still kind of in the theoretical phases, or if you're trying to build a building tomorrow, are you able to try to start sourcing things that are green steel, low emission concrete?
So the good news is that there is more of a market shift to offering these as options. They may not be available in every market yet, but we are seeing options for reducing the carbon footprint of concrete through the use of different additives in the concrete. Certainly steel and even an aluminum, even though we're not seeing aluminum obviously as a full building structure, it's still a building material, highly recyclable, highly recycled. Um, so in terms of reducing the overall footprint, those are still very viable options for a lower carbon building. We're seeing right now approximately half of a building's embodied carbon footprint is related to the building structure itself. So the footings and foundations, the columns, the joists, everything that makes the building stand up essentially. And those are those heavy hitters. That's concrete, that's steel. Um, One other viable option, which I know we're exploring pretty fervently here in the Mid Atlantic, is the use of heavy timber construction. We are not known necessarily for our timber and forestry in this area, but whether that is true, large format timbers, or whether that's engineered lumber, which is, large pieces that are kind of glued together from smaller pieces of wood. Um, Wood is a great natural renewable resource. It's a carbon sink. It actually holds on to carbon because of what trees do through transpiration and photosynthesis. So wood is sort of reemerging as another viable option, and I know that there are places in the United States and abroad that are even testing it for more of a high-rise option to
Oh
see
wow.
how that works when you get above 5, 6, 7 stories. But there are good options out there, and you have to kind of weigh them against what are all the other things that we want the building to do. It's got to meet building codes in terms of safety and security. It may have to meet certain fire resistance ratings. So it's often a balancing act where you have to select the right structural system that balances not just uh, sustainability and eco-friendliness, but also um, making sure that your occupants are safe, making sure the building has stability, and that it can last for the number of years that the occupants want it to last.
So it sounds like, if I'm hearing you right, about half of the sort of upfront carbon is associated with materials, and it sounds like there's you know different options, whether trying to buy, let's say, a greener steel or moving to something like a laminated or engineered wood. Um, and you're sort of making those decisions, kind of weighing pros and cons to determine what's best. What if we were sort of step back, and I think you're speaking to some of this already, but what are kind of macro level some of the other solutions to addressing emissions from kind of the new construction space? So it sounds like material selection, transportation, how stuff gets to the site. Are there other things that that folks need to think about to really create a low climate impact building?
Sure. Well, I think, again, we kind of look at it from both the operational standpoint and the embodied carbon standpoint. From the operational standpoint, especially when you're talking about new construction, we often look for ways to reduce energy consumption on a building to really minimize the footprint from that standpoint. So let's start by designing the most conserving building we can do. And we do that sometimes with very simple, very passive solutions. Things like understanding the building's orientation in relation to the sun, in relation to maybe existing or planned tree canopy for shade, prevailing winds also for breezes. We look at lower energy intensive building systems when we start to think about how the building is powered and heated. So whether that's geothermal wells that use the constant temperature below the Earth's surface to heat or cool the building, heat exchangers. And then we also look at, as I mentioned earlier, on-site energy generation. So photovoltaics on the roof for solar energy, but we're also seeing projects that could benefit from wind energy, from localized wind patterns. If you're near a coastline, it could be hydroelectric, for example. We had a project in the DC area. Unfortunately, it wasn't one of ours, but we had a project that actually took advantage of the constant heat in sewer water because
Oh, interesting.
wastewater is at a higher temperature consistently and used that as a heat exchanger to keep the building cooler in the summer. So we're seeing a lot of innovation in this realm because we realize that photovoltaics are great and the sun's energy is plentiful, but in that denser urban environment we were talking about earlier, you may be competing for sunlight with buildings around you. So you have to get creative in terms of how you might generate some of that power that you need on site. And so we've, through all of those different processes, we kind of try to reduce the energy consumption we think we're even going to start with. And then we can look at the grid and see what we might have to do to offset some of what's being provided by the local utility. When we look at the materials that make up the building, we as architects are becoming more engaged with carbon analysis and trying to select materials that balance beauty, function, durability, and lowering the emissions related to them. And there's a lot of data out there for understanding that, thanks to manufacturers who are willing to be more transparent about their processes. Many products now have these labels, environmental product declarations or EPDs, that allow us to understand what the global warming impact of selecting a product is, as well as what the manufacturer is doing to improve that through their own processes. We're also seeing some parts of the construction industry take back their products when the building or an interior space is demolished. We refer to this as take back programs. Some people call it the circular economy, but really these products are being taken back for recycling or upcycling to take back, for example, carpet tile or ceiling tiles are two that are often taken back and ground up and reused as new material for a new product. I wasn't moving enough, so the lights went off.
So, so that's exciting to hear. So I think, if I'm understanding correctly, first and foremost, you're talking about material selection. You're talking about designing a building that is efficient, which, folks might be connecting the dots, but if it's a more efficient building, it requires less power. And by virtue of that, since our electricity mix isn't 100% clean, that's saving carbon as well. Can you give folks a sense, I'm wondering if as they're listening to this, of kind of, you said embodied carbon is roughly 50%, if I understood you right, of embodied carbon comes from the materials. What are the other kind of big buckets, in terms of the carbon emissions of a building?
Yep. So about 50% come from the structure of the building, the superstructure of the building. The other big buckets tend to be the building envelope, so the exterior walls, including all of the glass and doors and anything that makes up the edge between the inside and the outside. Finish materials, so things like carpet, ceilings, paint, wall coverings, that usually makes up around 11%. What's a little unfortunate right now is that carbon accounting has come a long way in the past decade, but certain segments of the building industry are a little behind in being able to demonstrate this information. So much of the rest of it tends to be from building systems like mechanical systems and electrical systems, but there's a lot less data out there for us to benchmark against for things like an air conditioning system or a full electrical lighting system, because so much of it is customizable to the building. Every piece of ductwork is going to be a little different in my building versus your building. The size cooling tower on the top of the building on my building may be slightly different than on your building. And that's going to have an impact on that carbon assessment. So we're starting to see some of those segments of the building industry really catch up and make good strides. But there's still a little bit of work to be done to get everybody to the same point where we can truly benchmark to say that we're truly reducing that embodied carbon across all sectors of the building industry.
So getting better, but work still to go in terms of understanding all the ins and outs.
Exactly.
Um, and then how, roughly speaking, I mean, you've got the embodied carbon sort of, in the initial structure. How does that compare kind of to the operational carbon? I assume that depends too on the design, but, is it kind of half and half? How does that operational piece compare to the embodied piece?
We see typically it's been tracking almost 50-50, and that's from data I think that takes us through about 2018, 2019. Um, it does. The answer to almost every question I've found in architecture is it depends, because it
Right.
depends on what the design is, and it depends on how the users are using it. You can really reduce that in operational carbon, from an electrical standpoint, by putting your lights on timers and sensors and using super efficient LED lighting. But if people walk through and turn the lights on every time they walk through and forget to turn them off, or if they override the sensors, then it's also not going to work the way it was designed, and you're going to actually use more energy than it was designed to use. So I think we see it's a rough split of 50-50. What's interesting too is that buildings have a lifespan, just like there's we all have a birth and an eventual a death. So do buildings. Some buildings we keep around for a lot longer. So that embodied carbon, it's there in that building. It never goes away, but it's not like it's constantly being replaced. When we knock
Sure.
down a building and get rid of it and put a new building in its place, we're essentially starting again with all that embodied carbon. And what's interesting in commercial buildings is you build a building and it represents a certain amount of embodied carbon. If you've got many tenants in that commercial building and they've got 7-year leases, 10-year leases, and then they leave, there's a lot of turnover in the finishes and in the lighting and in the furniture of those existing spaces within the building, such that if that building lasts for 70, 80 years, the carbon represented by all of those interior build outs ends up being more than the building itself.
Oh, interesting.
So we're seeing that not only do we have to be cognizant of the structure, which initially is about 50% of that embodied carbon, but as we move forward in that building's lifespan, every time it goes through a renovation, that embodied carbon just gets greater and greater, especially if you're pulling things out, putting them in a landfill, or pulling things out and not recycling them or not upcycling them. So it becomes an interesting conversation when you're designing these spaces, especially interior spaces in a commercial building, to say, we know that you want to make this space your own, but what do you think we could keep? What could we reuse or repurpose? What could you get benefit from that's already there? And that's another way that we start to think about reducing the project's embodied carbon, is saying, like, sometimes reuse and preservation is one of the best initial solutions.
Oh, that makes sense. Yeah. So I guess, when you're redoing a kitchen, what can you keep in place and take advantage of? Maybe you're putting new cabinet, finishes on, or sorry, putting new,
Yeah,
door fronts and cabinets, but you're not replacing the whole structure, and that there's value in that.
exactly.
So we're talking, I think, about it here a little bit, but you know, new construction, I feel like we've kind of covered the bases. What about, remodeling and renovating structures? Um, what kind of solutions are sort of available there? And I don't know if there's other sort of relevant things to kind of highlight when we're talking about, you know, remodeling existing structures. But obviously, we're building new stock all the time, but we have all this existing stock that's out there.
Yeah. Um, yeah, the old cliche with sustainability is the greenest building is the one that's already built. And I feel like a broken record when I say it, but it's true. Existing buildings in some way are, I wouldn't say the golden ticket to lowering emissions, but it's a great start in terms of what we can save and what we can salvage and reuse. They're already built. The American Institute of Architects estimates that the United States has 6 million existing non-residential buildings. And that means that's roughly over 90 billion square feet of usable space. That's a lot of space that could be repurposed instead of a building being replaced. The challenge is that about half of that is 40 years old or more. So those are buildings that might still have great bones, shall we say. If the structure of a building is like its skeleton, it may be having challenges with its respiratory system or its circulatory system. So we need to look at modernizing these buildings for energy efficiency and updating the systems that might need replacement. This gives us an opportunity not just to bring them up to building code levels or minimum levels of safety and security, but also potentially improve the conservation, the energy conservation of these existing structures. If we think about what I said earlier, that we're looking at a structure of a new building being about 50% of its embodied carbon, imagine keeping all of that. So now
Right.
you're starting with a minimum of 50% less or thereabouts. That's a great way to start reducing the carbon footprint of the project. And that goes for any, whether it's a residential, single family residential or the tallest of commercial office buildings. Anything that you can salvage has value. And so how do we enhance that? How do we use what's already there to the best of our abilities? And then make the building as a whole as efficient as possible so that we're really prolonging the life of that existing facility.
And I'm guessing while salvaging is obviously
Mm-hmm.
valuable from a climate and broader sort of resources conservation perspective, that sometimes the labor, if you will, to dismantle um, can be high, right? And so, some folks might be incentivized just to tear down and rebuild. Are there, you know, incentives out there, or increasing number of incentives to encourage reuse of materials? I guess I'm wondering, like, what's what's happening out there um, to encourage that type of behavior, right? The reuse versus getting rid of. And I know I put you on the spot there,
That's okay. Um,
and you could talk generalities. I guess I'm just
yeah,
wondering what.
but yeah, I think that so some of this comes down to local municipalities, because as much as we often look at large government, big government to make sweeping, changes or legislation or mandates, a lot of where the rubber hits the road is in the cities and counties that adopt building codes, zoning codes, and other um, rules and regulations that govern how we build our buildings and how we design our buildings. And some municipalities are taking it further. Certainly, there are some incentives from a zoning standpoint. If you can accommodate an existing building, you might get bonuses for density to build on top of. There are programs out there where if you preserve outdoor space, you may get a building density to create an addition. And there are certainly tax incentives out there for retaining existing property, especially if it is deemed historic. So some of it is very localized, and as it probably should be, because those are the entities that are responsible for permitting and approving projects. So we see that a little bit more aggressively, maybe at the city and the county level, than we do more sweeping policy changes.
Interesting. So it sounds like it you've probably got jurisdictions out there that are more progressive and thinking ahead, and then in turn, putting um, putting rules and regulations in place around the built environment that are encouraging that sort of thing. Which leads me to kind of another question. I mean, are there, you know, we're talking here about all the details that go into a building and how to make it efficient. Are there examples of, cities or regions that you're aware of that are doing a good job at this, right? That of encouraging that, kind of climate positive building that we need to have to be able to reduce the sector's emissions.
Yeah, and I think, maybe as a side note, we've seen a lot of political turmoil in the United States over the past 6 or 8 years or so, and there was a lot of concern that with changes at the federal level, that we were going to see the aggressive nature of climate positive legislation go away. And I think, to my point earlier, we actually saw it transition from the federal government more to the local government. We saw governors and mayors really stepping up and saying, we need to promote this locally. We need to take this seriously. So we've got cities like my own. I live in Washington, D.C. We have a fairly aggressive climate adaptation plan. Um, we have almost over a decade ago now, they introduced the DC Green Code, which mandated certain levels of sustainable design for projects over a certain number of square feet, or if it was city funded. We also have the Green Area Ratio, which is a zoning ordinance that lets you choose how you deal with stormwater management on your site. But essentially, it's almost like they've gamified it a little bit, where um, they give you points for different strategies, whether it be a green roof or a green wall or bioswales, things like that. Um, Certainly, we see some more aggressive legislation and requirements on the coasts, especially when it relates to things like uh, sea level rise and the protection of spaces. I know City of Vancouver is pretty aggressive with requiring some level of resilience planning on all of their projects. We don't tend to see as much yet about embodied carbon, because I think, like I said, benchmarking has been a challenge, and it's been a bigger conversation over the past decade than perhaps in the past. So it wouldn't surprise me if we start to see more of that in the next 3 to 5 years. I also think that programs like the LEED rating system through the US Green Building Council have really done a lot to push the market, sometimes when it wasn't ready to be pushed. And I know that there is a new version of that rating system coming out in the next year and a half that will speak to embodied carbon and climate positive design. So I think that will also start to have an impact on how different cities, counties, and states might view requirements for projects in the future.
Well, it's good to hear that this stuff has continued to move forward, kind of despite what might be going on at a federal level, that it has momentum. And I guess you're speaking to this already to some degree, but wondering, if a lot of this resides with local municipalities and so forth. I mean, where do you see the opportunity? Like, if you were, let's say, in charge of a city, right? What are the kinds of things that maybe are just sort of on the edge of, folks' knowledge that could be incorporated into, zoning and building regulations that would help? Are there big opportunities out there that haven't yet been kind of adopted?
I think that building codes and ordinances can really be either carrot or stick.
Okay.
Um, and I would prefer it to be a carrot. So I would err on the side of saying it would be great to see more zoning codes in particular allow for either greater building density, greater heights, something like that, for encouraging climate positive design. And whether that be providing a full life cycle carbon assessment for a building to show how you, as a project team, have reduced the embodied carbon of a project, or and some municipalities do grant you leniency on the number of parking spaces, for example, you have to provide if you're near public transit. City of Seattle, I know, was doing away with parking requirements completely in certain portions of the downtown area. even for large buildings, because they wanted to encourage people to take greener methods of transit. So I think there's opportunity there to encourage the design of more climate positive structures by using building ordinances as incentive, as opposed to it being punitive or feeling like you have to drag people kicking and screaming.
Right.
I also think that there's probably a groundswell of people being more and more savvy about this who aren't in the design and construction industry. So end users and occupants are going to start asking for this more. Why aren't we designing a climate positive building? Or why isn't our building climate neutral? Why are we using fossil fuels? I mentioned earlier, that the younger generations are very empowered in understanding big data and using it to inform their decisions. It was only about, I would say, 15 years ago where I remember when they would review a new building in the Washington Post that achieved a LEED rating system certification, they would spell out what the acronym LEED stood for, and then in parentheses explain who the US Green Building Council was. And it's been about 8 years, maybe between the last 5 and 8 years, where they no longer have to do that. They can just say a LEED silver building. And if the Washington Post feels like they don't have to explain what it is to their readers anymore, to me, that's a good sense of saying we're dealing with a savvy population who knows what it means and who knows what to ask for. So I'm hoping that in the future, not only will building codes reward that climate positive design, but I also hope that we're going to see a lot more end users and the people actually paying for these buildings asking for it or demanding it.
Interesting. Well, I hadn't thought about it as a, excuse me. Interesting. Well, I hadn't thought about it as, the sort of end consumers, like let's say a condo owner, homeowner driving some of that demand. But that obviously would be, is a positive development if that's occurring. Um, you know, I guess I'm wondering as we're talking about all this, and somebody might be listening and thinking that this is really interesting, but you know, how do I get involved in terms of being able to affect change in the building space if I'm, not an architect or an engineer? What would you suggest to folks if they want to be part of, helping their community become greener from a built perspective?
I think there's a lot you can do as an individual, and some of it is going to feel like you're going to have to start at home. So understanding it in your home and at that scale is going to help you understand it at a greater scale. So whether it's using programmable thermostats, or upgrading insulation in your home, even adding solar power to your roof if it's viable to do so, these are all going to help you lower your personal carbon emissions from your home. And the scale of that translates then, everything can scale up to larger buildings. I do think on a larger scale, even especially if you're not directly involved in the design and construction of buildings in your area, a few things come to mind. The first is a theme we hear so often in climate design and climate justice. It's to advocate. Local jurisdictions are where the rubber meets the road. So asking your city or your county governments for more aggressive energy conservation requirements and advocating for the local grid to move to cleaner sources are two things that are going to have a wider impact than just one house or one neighborhood.
Sure.
I think the second is to educate yourself where you feel like you need to learn more and then speak up. If you work in a commercial office building or any sort of large professional space, whether that's higher education or healthcare or even a warehouse, ask about how the building is powered. Ask about what your company's doing to commit to carbon reduction. Companies are talking about their ESG goals, their energy. Companies are asking about their ESG goals, their environmental, social, and governance goals all the time. And it's great when employees actually engage with those goals and take ownership of them themselves. And the last thing I would say is to vote with your wallet. Just that probably one of the easiest things to do is to support companies that are working towards cleaner energy, that do support take back programs to recycle or repurpose their goods, and that offer transparency in their manufacturing processes. In the era of big data, it's really easy to find this information, and it's really easy to make a choice to say, I'm going to support a certain segment of the economy that aligns with my goals.
Well, Jon, exciting to hear that there's so many different opportunities for folks to plug in, and we'll definitely, kind of call those out in our call to action for this episode. Um, Thanks for coming on to the show and sharing your wealth of expertise, helping us all be a little bit smarter when it comes to green building, and hopefully people go out and start paying more attention to what's around them.
Thanks for having me. It's been great.